All right, good morning, everybody. Welcome to today's live lesson. Hope you guys are excited. We're going to start looking at tests. Okay, so these are kind of practice tests that you guys can use to see what you can expect in the exams. So we're going to go through two papers. So this will be the progression test, okay, mathematics paper 1 and paper 2. So we'll go through these just to give you an idea of what to expect for the exams. Okay, so please work with me as we go through this exam. Okay, so I'll give a few tips on how to actually answer the questions and maybe how to study as well. Okay, so let's jump right in. So this will be how the paper will actually look when you finish this course and when you want to move on to IGCSE. Okay, so let's look at question 1. Work out the third term of the sequence with nth term 3n plus 2. Okay, so they are giving me the nth term. We can see it as Tn is equal to 3 times n plus 2. Okay, so that is technically what they are giving me. They are asking for the third term of the sequence. So they are asking for T3. Okay, so what do? All I do is I substitute 3 into n's place. Okay, remember that n represents the position. Okay, so n represents the position of the term. So this will be 3 times 3 plus 2. And this is equal to 3 times 5. Remember bid mass. And this is equal to 15. Okay, so T3 is equal to 15. Okay, let me just maybe make this a little bit smaller. Okay, there we go. Right, work out the size of an exterior angle of a pentagon. Okay. So this goes back to rules with regular polygons. Okay, we have a regular pentagon, which means that we have 5 sides of equal length, and all of my exterior angles and interior angles are the same. Okay, so how do we calculate this? So if you didn't know, I quickly want to show you something. If we take all of my exterior angles, okay, so these are my exterior angles. So if we take them and we actually add them together. So look at what I'm doing here. I'm taking all of my exterior angles, and now I'm just adding them together. Okay, so this is a good way to visualize what happens to the exterior angles, or how we can actually calculate them. Okay, so we can see that they actually sum to 360 degrees. Okay, so if we want to calculate one of these exterior angles, what do? What we do is we say that the sum of my exterior angles is equal to 360 degrees. So that means that if I want to get my angle, so this angle will just be equal to 360 divided by how many angles there are. Okay, so we have 5 exterior angles. Okay, so can you see that we are essentially calculating this by taking all of these angles? So we're taking 360 and dividing it by 5. Okay, so 360 divided by 5. I think that's 72, if I'm not mistaken. Okay, so yes, indeed. So it is equal to 72 degrees. Okay, there we go. And this is also a rule that you have to study. So my exterior angles, the sum of my exterior angles is equal to 360. And if I want to calculate the exterior angle, we just say 360 divided by how many sides or how many angles there are. Okay, this is a pentagon. If this was a hexagon, for instance, we could have just said divided by 6. Okay, so easy question. There we go, we have 2 marks. Moving on. So the table shows the age and value of 7 cars. Complete the scatter graph. Okay, so this might take a little bit long, but we'll do it very quickly. So we just have to complete the scatter graph. So we have X values, or we have values for the age of the cars in years. And then over here, we have the value in dollars. Okay, so let's look at how we are going to complete this. So I'll actually take it in ascending order. So I'll start off with an age of 5. Okay, so we'll see here that this is not ordered from smallest to biggest. So I'm just going to do that myself. So if I start with an age of 5, it has to have a value of 2,700. So here's 5, and here is 2,000, 2,700. So this is 2, 4, 6, 8. So approximately over there. Okay. So this is 2,700. So I can see that these are actually divided up into 200. So this is just 2,200, 2,400, 600, 800. So 700 is right there in the middle. Okay, so that's my first one. So we'll do 5, and then we can do 7. So 7 is 2,900. Okay, so here's 7, and 2,900 will be right about there. Okay, so that's actually 200 more. Right, and then for 8, we have 2,200. So that's an easy one. 2,200, that's right there. And then our two last ones, we have 9 and 1,200. 9 and 1,000, that's approximately, so let's just make sure. So this is 1,000, and we're looking for 1,200. There we go. Okay, I can erase that. And then for 10, we have 500. Okay, 10 and 500, so this is 2, 4, 500 is over there. Okay, so easy 2 marks. We just plot those coordinates. Okay, plot the age of the cars versus the values. Right, B, write down the type of correlation. Okay, so we have 2 types of correlations. Okay, so 2 main types. We have a positive correlation where all of these coordinates are going in a positive direction. So positive, it's going upwards. But in this case, we can see that it has a negative correlation. So everything is going downwards. Okay, so this has a negative correlation. Okay, great stuff. Moving on. Okay, tick to show whether each of these statements is true or false. Do not do any calculations. The first one has been done for you. Okay, so we can't do any calculations. We just have to state whether this is true or false. So let's look at this one. The answer to 17.4 times 0.82 is larger than 17.4. Okay, now that doesn't make sense. This number is smaller than 1. Okay, so if we multiply by a decimal that's smaller than 1, then answer has to be smaller than my original number. Okay, because this is actually going to be 80% of my original number. Okay, so this is definitely false. Okay, and that really makes sense. If we are multiplying by a decimal that's larger than 1, the original number has to increase. Okay, if it's smaller than 1, the original number has to decrease. Okay, so let's look at the next one. So the answer to 23.8 divided by 0.74 is smaller than 23.8. Okay, so now we have to be careful because now we are essentially dividing by a number that's smaller than 1. Okay, so that means that this number has to increase. Okay, so this is also false. Okay, great. And if this number was greater than 1, then this number would decrease. Okay, so that's also part of a little bit of study work. Right, question 5. So I'm trying to move quickly through these questions. We have to get through both papers. Okay, question 5a. A cuboid measures 5 centimeter by 4 centimeter by 3 centimeter. For the cuboid on the isometric grid. Okay, so very simple. They give me the length, they give me the width and the height. And I just need to draw it. I need to draw this 3D shape. Okay, so we're going 5 by 4 by 3. Okay, so let's just draw it anyway. So we have to go 5 units. So 1, 2, 3, 4, 5. Okay, so there's 5 units. So 5 by 4. 1, 2, 3, 4. And my height is 3. Okay, so this is my height. 1, 2, 3. And now we can just connect all of my sides. There we go. Okay, we connect all of the sides. Okay, and there's my cuboid. We have the length, so let's just double check. So this is 1, 2, 3, 4, 5. Okay, that's correct. So this is 5 centimeters. This is 4 centimeters. And here we have a height of 3 centimeters. Okay, and that looks very good. Right, moving on. Write down the number of planes of reflectional symmetry. Okay, what is reflectional symmetry? Okay, so that just means if I cut this shape in half anyway, then those two shapes have to be exactly identical on both sides. Okay, so that's what symmetry means. Remember, if you look at your face in the mirror, the one side of your face, if you cut your face in half, it has a reflectional symmetry. Okay, so the one side will look exactly the same as the other side. So if you look at the shape, how many times can we actually cut it so that it has exactly the same size? Okay, so we can actually cut it 3 times. If you look at it, we can cut it in half right here on the center. Okay, so this will be my cross section. So there's the one. So the one block looks exactly the same as the other block. Okay, so we have reflectional symmetry. And then we can cut it down the middle. Okay, so there's another one. So 1 and 2. So let me actually leave this one in as well. Okay, so there's the one reflectional symmetry. And then here's my other one. Okay, so we will have 3. Okay, so once, twice, and we will have 3. Right, there we go. 2 marks. Moving on. So put a ring around the value that is closest to the cube root of 70. Okay, how are we going to do this? They give me a bunch of decimal values. Okay. And we need to say which value is closest to the cube root of 70. So how can we actually determine this? So let's quickly look at the actual cube numbers. So if you think about the cube numbers, you start off with 1. It's 1 times 1 times 1 is 1. And then if you take 2, so that's 2 times 2 times 2 is 8. And then 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. Then 5 times 5 times 5 is 125. Okay, so these are my cube numbers. So these are few cube numbers. Which means that if I take the square root of these numbers, okay, so the square root, well, cube root, not square root, the cube root of 8, cube root, there we go. Okay, so that will be equal to, so this is 1, 2, 3, 4, and 5. Okay, so which of these is closest to the cube root of 70? So the cube root of 70 will actually be over here. So let's change the color here. So the cube root of 70 will be right here in the middle between 4 and 5. Okay, so we can see that this 4.1 is closest to this number. Okay, so can you see that? If we know that the cube root of 64 is 4 and the cube root of 125 is 5, that means that the cube root of 70 has to be between 4 and 5. Okay, so that means that the closest one is 4.1. Okay, so that's a very nice way that we can determine it. We can just look at the cube numbers and see where these decimal places are closest. Okay, there we go, 1 mark. Moving on. Okay, let's look at question 7. Here is a pattern. The rule is to simply multiply the values in the top 2 circles, make the value in the bottom circle. Complete these patterns using the same rule. Okay, so this looks like we are multiplying 5 and 3, which gives me the answer of 15. So 5 times 3 is equal to 15. Okay, so if you look at these bottom ones, so complete these patterns using the same rule. Okay, so that makes sense. We have to say minus 8 times minus 0.5. Okay, so what happens if we multiply by a half? So that means that we are essentially taking this and dividing it by 2. If we write this down, so minus 8 times minus 0.5, we can write this minus 0.5 as a fraction. So we can say that this is actually minus 8 times minus a half. Okay, if you guys remember how to multiply fractions, remember if you have a whole number, just multiply at the top. Okay, so if this is over 1, multiply at the top, multiply at the bottom. So this is just minus 8 over 2, minus 8 over minus 2. Okay, which becomes a positive, and we have is equal to 4. So this will be my answer. Minus 8 times minus 0.5 is equal to 4. Okay, great. That looks good. Now for B. Okay, so it looks like we have a few indices and we have variables as well. So now we have to focus. Okay, so for B, 8p to the power of 4 times something. Okay, so now we do not know what it's being multiplied with. It's equal to 24p to the power of 12. Okay, so now we have to think back to indices rules. Okay, remember, if we think about indices rules, if we have, let's say, p to the 4 times p to the 3, just for instance, okay, this means that I have to add my indices. So this becomes p to the power of 4 plus 3, or we can see it as p to the power of 7. Okay, so if we multiply bases, okay, so the same bases with indices, we have to add the indices. Okay, so how did we get from p to the 4 to p to the 12? Okay, so we had to add 8, which means that we had to multiply with p to the power of 8. Okay, and that makes sense. So that one is easy. So to get to p to the 12, we have to multiply with p to the power of 8. Okay, and then how to get from 8 to 24? We just multiply by 3. Okay, because 8 times 3 is equal to 24. So this is 3p to the 8. Okay. Another way that we could have done it, okay, and this might be a little bit advanced, but if you want to do it like this, you definitely can. You can write an equation for this. You can say that this is actually 8p to the 4 times x, okay, because x is my variable. This is, I don't know what this value is. This is equal to 24p to the power of 12. Okay, so how do we solve for x? How do we get what I'm multiplying with? We just divide by 8p to the 4. So what we do on the one side, we have to do on the other side. So this is 8p to the power of 4. And what is 24 divided by 8? So that's just equal to 3. And what is p to the power of 12 divided by p to the power of 4? That is just equal to p to the power of 8. Okay, remember, if we divide now with bases, with indices, okay, with the same bases that have different indices, we have to subtract. So this is 12 minus 4 is equal to 8. Okay, so another way that we could have done that. Right, great stuff. So we have 2 marks. Okay, factorizing. Okay, factorize fully. What is factorizing? Remember, we are taking out a common factor. Let's look at these two. What is my common factor between 2a squared and 5a? Okay, so a common factor would just be, okay, so my common factor. This is also a good practice to always write down your common factor before trying to factorize. So in this case, it's just a. So my common factor is equal to a. Both this term and this term contains an a. So that means that I have to take out an a. So if I take out a, what will be left? Okay, so we will have a 2a. And in this term, what will be left is a 5. Okay. So remember, this is just the reverse of the distributive rule. Okay, so we're taking out, or we're technically dividing by a, and we're taking this a out. Okay, if we multiply this, if we distribute this a back into the brackets, we will get back to my original term. Okay, that one was easy. We take out an a, what's left is 2a plus 5. Okay, next one, 6 minus 18x plus 24y. Okay, so what is my only common factor between these 3 terms? So I can only see one. My common factor, okay, so I'm going to say my highest common factor is just equal to 6. Because all 3 of these terms have the factor of 6. So if I take out 6, what will be left in all 3 of these terms? Okay, so we will have 1 minus 3x plus, so what's 24y divided by 6? So this is just plus 4y. Okay, and remember that you can test this. You can test it, you can just multiply or distribute this back into the brackets. If you get to your original answer, know that you have factorized correctly. Okay, great stuff. All right, so draw lines to join each calculation to the correct answer. Okay, so with these types of questions, I just always suggest to actually do the questions. So do the questions, the answers. So maybe do it on a separate piece of paper, and then you can join the lines. Okay, so let's start with the first one. Let me just quickly move something here. Okay, so this one is done. So this is just 3 times 2 plus 4, which is 3 times 6, and that's 18. Let's do the first one. We have 0.5 plus 1.5 times 3. Okay, so if we convert this to fractions, so this will just be a half plus 1.5 is 3 over 2 times 3. Okay, so this will be a half plus this is 9 over 2. Okay, so this would just be 10 over 2. Okay, remember we have the same denominators, so we can add the fractions. So this is 10 over 2, which is equal to 5. Okay, so that's my first one. Okay, let me just put it, I'll leave it there. Right, so for this first one, this goes to 5. Okay, and then for the next one, we have 8 minus 1 times 2. Okay, remember we are doing mass. Okay, so we first multiply and then we subtract. We don't say 8 minus 1 is 7 and then times that by 2. We have to remember bit mass. Okay, so brackets first, indices, division, multiplication, addition, and then subtraction. Okay, remember your bit mass. So this would just be 8 minus 2. Yeah, I'll put it there. So 8 minus 2, and this is equal to 6. Okay, so let's connect that one. And then the next one, so 10 plus 2 to the power of 3 minus 4. Okay, so let's do that here. So this is 8 plus 2 cubed minus 4. So 2 cubed is just 8. Okay, so remember, do your indices first. So 10 plus 8 minus 4. So this is 18 minus 4, and 18 minus 4 is equal to 14. Okay, great. So this one goes to 14. That looks good. Okay. And then for the next one, okay, so we have 2 squared plus 1 times 8. Okay, so now we have to do our indices first, so 2 squared, and then we have to do the brackets, and only then we multiply. Okay, so this would be 4 plus 1 times 8, and that's equal to 5 times 8, and this is equal to 40. Okay, so this just goes to 40. All right, so easy one, 2 marks. Moving on. Okay, so yeah, as I said, with these types of questions, you can just do the actual calculations and just see what the answers are. Okay, so don't try and just guess and see if you can figure it out just by looking at it. It's really helpful if you just put it on a separate piece of paper or just do it on the actual page in pencil. Okay, some good advice. Okay, work out 2 6 plus 1 3/5. Okay, so firstly, always convert. If you ever have mixed numbers, okay, convert mixed numbers first. Okay, so this is a very big tip. Whenever you see a mixed number, always first convert it. So how do we convert this? So we have 2 times 6 plus 1 over 6. Okay, so this is 12. So this is 13 over 6. And if you don't know how to convert mixed numbers to improper fractions, go revise that before attempting this. Okay, so plus, this is 1 times 5 plus 3 over 5. Okay, so we have 8 over 5. And now we just have to add these two. Can we just simply add them? No. If we add or subtract fractions with different denominators, we first have to get a common multiple between the two. Okay, so what is my lowest common denominator? So in this case, it's just 30. So we multiply. We can multiply by 6. Let's see, is there actually one that's a bit closer? We can get to, okay, no, so 30 would be the closest. So we have 6 over 6, and over here we multiply by 5 over 5. So what's 5 times 13? Okay, so this looks like it would be 65, I think. Yes, okay, 65 over 30. Plus, okay, we can actually already put it over the same denominator because that's why we are doing it. Okay, plus then we have 8 times 6, so that's 36, 42. Wow, 8 times 6, 48. Okay, so plus 48. Obviously not necessary to use a calculator, but I'm just doing this very quickly. Okay, and this is equal to, so 65 plus 48. Okay, what is 65 plus 48? Just to do it very quickly, so we have 113 over 30. Okay, so that looks good, 130 over 30. So we can actually convert this back to a mixed number, but they don't specify, so I'm just going to leave this as an improper fraction. Okay, so there we go, our 2 marks. Okay, looking good. Okay, describe fully the single transformation that maps A onto B. Okay, so we can see that this almost looks like maybe rotation, or it can be a reflection. So it can be a reflection around a certain line of reflection. And how do we determine that line of reflection? So we can look at exactly the perpendicular bisector between the vertices. Okay, so when we did transformations, remember that when we have a reflection, it's just like the planes of reflection that we spoke about when we had that cuboid. Okay, so now we will have exactly 2 sides which are exactly symmetrical, and the distance between them, okay, so the distance between them are exactly the same. So we have to divide this line in 2. So this will be my line of reflection, okay, or my reflection line. So this is just y is equal to 2. Okay, so that's my reflection line. So our single transformation is just a reflection about y is equal to about or around y is equal to 2. Okay, so we get 2 marks for this. The 1 is for the actual transformation, which is the reflection, and then my mirror line. Okay, so this is just my mirror line. Right, there we go, 2 marks, easy stuff. Okay, moving on, we are almost halfway. This one, work out 7 to the power of 0. Okay, remember, anything to the power of 0 is just equal to 1. Okay, so even if I have a billion and I raise it to the power of 0, the answer would be equal to 1. Okay, so anything to the power of 0 is equal to 1. Okay, it doesn't matter what that is. Okay, we can actually just say x to the power of 0 is equal to 1, where x just represents any base number. Okay, work out. So 24.73 divided by 0.001. Okay, how are we going to do this? So 24.73 divided by, now I'm actually going to write this 0.001 as 1 over 1,000. Okay, so we can actually do that. This decimal is just 1 over 1,000. Now we can take this division sign and we can tip in times. So we can turn this into a multiply, and we can switch this numerator and denominator. So this becomes 24.73 times 1,000. Okay, and what do we do if we multiply by powers of 10? We just move our decimal point to the right. Okay, so this will move to the right 3 times. So my answer is just equal to 2473. Okay, where my decimal point moved from there 1 to 3 times. Okay, there we go. Easy stuff. Right, number 14. Okay, this will be my last one. Here is a circle with center C. Construct an inscribed regular hexagon. Use only a pair of compasses and a ruler. Okay, so I do not have a compass on here, but what I will do is I'll quickly share my other screen. When I've prepared a compass, I looked at this question and just realized that I don't have a compass. But okay, so here we have it. So in this case, we just have a circle. We don't know what the circumference is. We don't know what lengths of the regular hexagon or the sides of the regular hexagon is. So what we're going to do is the following. Okay, and this is a method to construct a regular hexagon. Okay, so if this was our original circle, okay, let me just quickly let's make this a little bit smaller. So if this was my original circle, so how we actually go about drawing a hexagon is we take, what do we do is we take exactly the radius of this circle. Okay, so we take this radius of the circle and then we just place this compass on the side or on the circumference of the circle. Okay, so let me quickly make this a little bit thinner. And then we make construction lines. So we start off, and there's my first construction line. And then you go to the vertice of where this new construction line actually cut the original circle. And then you make another construction line. You go to the next vertice, another construction line. And to the next one, make a construction line. And then to the final one, and you make another construction line. Now, all of these vertices actually represent the vertices of, let me just make this another color. Okay, I can't really do this properly. Okay, but all of these vertices represent the vertices of my hexagon. Okay, so all we do now is we join these vertices. Okay, and this way you can construct a perfect regular hexagon. Okay, so I'm going to copy this and just put this on my original page. Okay, now obviously we would just erase all of these construction lines, and very important, always leave a few construction lines for the person marking actually see that you did use construction lines and that you didn't just use a ruler to construct the hexagon. Okay, so going back, there we go. Right, so that's basically how it would look if you would do it around the circle. So when you take your compass, open it up to the size of a radius, okay, and then you place it on the circumference, make a circle, okay, then go to that vertice, make the exact same circle, and so on and so forth until you've done that for all of the vertices, okay, and then you just connect them. And just to show you guys, this is how it looked. Okay, great stuff. So that's how we construct a regular hexagon using a pair of compasses, okay, and a ruler. All right, that's it, guys. So that's all we have time for. We're halfway through. Next week, we'll finish this and most likely start with paper 2. Okay, and then we'll finish up with that. All right, thank you very much, everyone, for joining. I will see you in the next lesson. Great day.